Christopher is trying to cross a river. His speed is 2.4 meters per second. The downstream current is 0.6 meter per second. Now, we're going to calculate the distance from the starting point to the end point, as you can see. To do that, I'm going to substitute 95 for SP, which is starting point, and 25 for the end point. This will equal to D squared equal to 95 squared plus 25 squared. D squared is equal to 9025 plus 625. This will equal to 9650. Now D is equal to square root 9650, which is equal to 98.2344. Now, this is the distance from the starting point to the end point. We're going to calculate theta. Theta is the angle he must swim in order to reach the end point. To find theta, we're going to find theta 1, and then we add theta 1 with theta 2. To find theta 1, I'm going to do tan inverse, as you can see, tan inverse 25 over 95, which is equal to 14.7436. Now, I'm going to find the external angle, which is, I'll call it alpha, as you can see here. To find that, I'm going to do 90 plus 14, as you can see here, 90 plus 14.7436, which is equal to 104.7436. Now I'm going to find theta 2 by using the law of sines with a triangle on the right. As you can see, this is the external angle, which is alpha, the current of the downstream, which is 0.6, and his speed, which is 2.4 meters per second. Now, as you can see, we're trying to find theta 2. Now, sine theta 2 over 0.6 is equal to sine 104.7436 over 2.4. As I said, I'm trying to find sine theta, which I'm trying to find theta 2. So we're going to do sine theta 2 equal 0.6 sine 104.7436 over 2.4. Theta 2 is equal to sine inverse 0.6 sine 104.7436 over 2.6, which will give us 13.9914. Now, to find theta using theta 1 and theta 2, we're going to add them together, which will give us the angle that he must swim at. So 14, as you can see here, 14.7436 plus 13.9914 is equal to 28.735. This is the angle he must swim at. Finding the time it will take him to cross the river. I'm going to use the law of sines again. So sine 104.736 over x equal to sine 61.2726 over 98.2344. Now we're trying to find the distance first. So x is equal to 98.2344 times sine 104.7436 over sine 61.276, which is equal to 108.333. This is the distance from the start point to the point he must swim at. Now to find the time is equal to distance over speed. So we need to find his average speed. So his average speed is square root 2.4 squared minus 0.6 squared, which is equal to 2.42379. Now we will use the distance and his speed to find the the time it took him to reach the endpoint. So 108.333 divided by 2.32379 is equal to 46.6191. The coach predicted that Christopher will not take more than 45 seconds. Now, using upper and lower bounds, 42.5 and 47.5. Anything greater than 42.5 and less than 47.5 will be rounded to 45. So my time was 46.6191, which can be rounded to 45. So the coach was right about the time. For the final part, Christopher is going to cross the river again in a terrible wind condition. His speed increased a bit. Now it's 2.5 meters per second. The current of the downstream also increased. It's now 3.2 meters per second. Now, using the law of sines, this case is ambiguous. What does that mean? It means that B is larger than A, so there's no triangle, because his speed is less than the speed of the downstream, which is 3.2. So there will be no triangle and the angle can't be found. In other words, he cannot reach the endpoint because there is no angle, there's no triangle. You cannot find the angle, so he can reach the endpoint. So 3 limitations and assumptions. The first thing that I didn't know was I didn't know how to, or I didn't know what's the degree of accuracy. So I had to research that, and then I actually found a very good source, which I'll put in the description of the video. This source helped me a lot to find the answer that I wanted and to move to the next part. The next limitation is I don't know how to find the angle that he must swim at. So I had to research, and I actually found something called law of sines. It helped me a lot. I'm going to also put the link of the website down in the description. So after I used the formula, okay, I found the angle 1 and angle 2 to find the final angle that he must swim at. For the last limitation, so I had to research the last part, which was him swimming in a terrible wind condition. So I found something called ambiguous cases. So there are many types, but the type that I wanted to find was when B is more than A. When B is more than A, the triangle there's no triangle. So there's no angle that he can swim at. Basically, as I said for the last part. So this source helped me a lot. It might help you also. I'll put it in the description. It shows all the types of the different cases. So that's it. Thank you for watching.